So the next time rain falls on your face or taps against your window, pause for a moment. Remember the invisible life it carries, the mysteries it contains, and the promise that even the simplest phenomena, the touch of a raindrop, can hold awe-inspiring secrets. Rain, the gentle patter against windows, a nourishing lifeline for the earth, and for centuries, an unexplained source of fascination. But what if I told you that rain is not just water falling from the sky? That within its silvery droplets lie a secret world teeming with life? This is the extraordinary mystery behind living rain, where microorganisms hitch a ride on water droplets to make their startling descent to the earth. A phenomenon as enigmatic as it is wondrous, it blurs the line between weather and biology, sparking questions that span the fields of science, ecology, and philosophy. Let's begin with what we know, or rather what we thought we knew. Rain, according to textbooks, is the product of the water cycle: evaporation, condensation, and precipitation. Water vapor rises into the atmosphere, cools, condenses into clouds, and eventually falls back to Earth as rain. Simple, right? But nature is rarely simplistic. Scientists have discovered that raindrops often carry more than water. They can host tiny hitchhikers, bacteria, fungal spores, algae, and viruses that survive their journey from the clouds to Earth. This realization has reshaped our understanding of rain, unveiling a marvel of microscopic ecosystems that thrive beyond our gaze. The first hint of this mystery came over a century ago, although at the time it puzzled early researchers more than it enlightened them. Farmers in remote areas occasionally noticed rain, discoloring their soil or staining their crops. But instead of washing away impurities, the rainfall introduced them. Red rain, black rain, and even yellow rain were reported in different parts of the world, anomalies that defied natural explanation. It was easy to assume that industrial pollution or volcanic ash in the atmosphere was to blame, but investigative studies revealed something much stranger. The colored rain sometimes contained organic material. There were spores, microscopic algae, and even cellular structures. But these incidents were considered rare curiosities, abnormalities rather than a broader phenomenon. Fast forward to the late 20th century, when tools like electron microscopes allowed scientists to zoom further into raindrops' microscopic contents. Routine samples of rainwater from clean environments, isolated from urban pollution, showed that rain didn't just occasionally carry traces of life, it almost always carried microorganisms. Microbial rain, as it came to be known, wasn't limited to specific regions or weather types. Across continents and climates, researchers were finding bacteria adapted to the airborne lifestyle, fungal spores that took advantage of updrafts, and algae transported thousands of miles from their original habitats. It turned out that life not only survives the atmosphere, it thrives within it. But how do organisms make their way into rain in the first place? The answer lies in tiny particles known as cloud condensation nuclei, or CCNs. CCNs are essential for rain formation, as water vapor needs something solid to cling to when condensing into droplets. While many CCNs are inorganic, aerosols, dust, or sea salt particles, a surprising number are biologically derived. Living microorganisms, or fragments of organic matter, unassumingly become part of this process. The bacteria that end up in clouds don't necessarily come from the air. They rise from the soil, water bodies, or vegetation, riding on dust and wind currents. Once up there, many organisms demonstrate resilience beyond imagination, surviving freezing temperatures, ultraviolet radiation, and low oxygen levels in the atmospheric layer. Once incorporated into raindrops, these microorganisms descend to Earth in a process of planetary recycling. To understand the scale of this transport, consider this. Researchers estimate that a single gram of surface soil contains more microbes than there are humans on Earth. Now imagine that bacteria and spores from one region might mix in the atmosphere with microbes from across oceans and fall into entirely unsuspecting ecosystems. Rain not only waters the Earth, it seeds it. These falling microorganisms may introduce genetic diversity, replenish depleted soils, or even affect the health of crops. While many organisms in rain are harmless or beneficial, the phenomenon has a darker side. Disease-causing pathogens, too, can hitch a ride on raindrops. In 2001, scientists studying an outbreak of Legionnaire's disease, a respiratory illness caused by the bacterium Legionella pneumophila, found evidence suggesting that contaminated rainfall dispersed the bacteria across communities. Similarly, airborne fungal spores carried by rainwater can trigger allergies and illnesses in humans susceptible to respiratory conditions. Viruses, although less studied in aerosolized rain, may find atmospheric transit pathways that we are only beginning to comprehend. This dual nature of microbial rain, as both a source of ecological diversity and a vector for disease, reflects the paradox inherent in nature's design. What's remarkable, too, is how microorganisms may influence the weather itself. Some species of bacteria, like Pseudomonas syringae, are known as bioprecipitation agents because they can raise the freezing temperature of water. When these bacteria are carried into clouds, they may act as catalysts for rainfall, encouraging frozen water to form and precipitate sooner than it otherwise might. In a way, microorganisms aren't just passive passengers in rain. Sometimes they're active participants in its creation. This adds another layer to the understanding of rain as part of a dynamic, interconnected system rather than a straightforward meteorological process. As scientific knowledge of microbial rain grows, researchers are exploring its broader implications. Could rain-borne life forms play a role in advancing agriculture, for example? Certain strains of beneficial bacteria are known to enhance plant growth, protect against pests, or improve soil health. Understanding the mechanisms by which microorganisms disperse via rainfall could allow scientists to harness these natural processes in innovative ways. On the other hand, climate change and increased pollution may disrupt centuries-old microbial transport systems, causing unforeseen ecological consequences. For instance, altering wind currents or increasing atmospheric temperatures might shift where and how microorganisms travel, impacting ecosystems that depend on rain-borne organisms for stability. From a philosophical perspective, the notion of living rain reminds us of the interconnectedness of life on Earth. Every raindrop falling on an open field or a city street carries echoes of other ecosystems, other lives. Microbial rain serves as a reminder that even the smallest facets of nature contribute to its complexity, weaving a global web that binds the soil, seas, skies, and human existence into one shared story. The next time rain falls, it's worth asking, what unseen travelers might it be carrying? What ancient life forms might be returning to the soil? Or what new introductions might be reshaping the world beneath our feet? Still, much about microbial rain remains a mystery. How many organisms survive their fall to Earth? What determines which species are launched into the atmosphere and which stay firmly rooted in their native environments? And could there be instances where microbial rain directly influences human evolution and adaptation? These questions are tantalizing glimpses into the deep unknown, a frontier at the crossroads of meteorology, biology, and ecology. In the grand scheme of life, rain has always been a symbol of renewal and growth, but understanding rain as the carrier of life itself extends its significance beyond the poetic. It underscores how life, in its infinite forms, adapts, evolves, and transcends boundaries. Whether nourishing crops or spreading disease, rain reflects the resilience and unpredictability of nature, a force that both nurtures and challenges humanity. And in every storm cloud, within every drop, lie microbial adventures as old as the earth and as boundless as the imagination. Rain carries stories, microscopic and otherwise. Hidden in its silver cascade is the proof that no force in nature exists in isolation. Like the threads of a tapestry, each part connects to another, forming an intricate design we're only beginning to decipher. So the next time rain falls on your face or taps against your window, pause for a moment. Remember the invisible life it carries, the mysteries it contains, and the promise that even the simplest phenomena, the touch of a raindrop, can hold awe-inspiring secrets.